We're tackling stormwater detention sizing and culvert hydraulics, a key topic in the Water Resources and Environmental Engineering section of the FE Civil exam. The core principle behind a detention basin is to ensure the peak outflow rate after development does not exceed the pre-development peak flow rate for a given design storm. The fundamental equation you'll use, found in the Hydrology/Water Resources section of the NCEES FE Reference Handbook, is based on a simple mass balance. The change in storage equals the inflow volume minus the outflow volume. On the exam, you'll likely be given an inflow hydrograph as a table of flow rates over time. You'll need to use a routing method like the storage indication or modified pulse method to determine the required storage volume. This involves stepping through time intervals, calculating the average inflow and outflow rates for each step, converting those rates to volumes by multiplying by the time interval, and then summing the changes in storage. A common exam trap is to mix up flow rates in cubic feet per second with volumes in cubic feet. Always ensure your units are consistent. You must multiply flow by time to get volume before you can calculate storage. Now let's shift to culvert hydraulics. A culvert is a pipe or channel that allows water to flow under a road or other obstruction. Its performance is governed by one of two conditions: inlet control or outlet control. Under inlet control, the flow is limited by the geometry of the culvert's entrance. Think of it as an orifice. The culvert barrel could carry more water, but the entrance restricts how much can get in. In this case, the culvert flows partially full with high-velocity, supercritical flow, and downstream conditions like tailwater depth are irrelevant. Under outlet control, the flow is limited by downstream conditions. This can be caused by high tailwater submerging the outlet or by the friction loss along the length of the culvert barrel itself. In outlet control, the culvert can flow either partially or completely full, and the flow is slower, subcritical. The FE exam will test your ability to determine which condition governs. For a given flow rate, you must calculate the required headwater depth, the water depth at the inlet, assuming both inlet control and then assuming outlet control. You'll use the specific nomographs and charts provided in the NCEES FE Reference Handbook for this. Here is the critical point and a major exam trap. The controlling condition is the one that results in the higher headwater depth. The culvert will only pass the design flow if the upstream water level is high enough to overcome the more restrictive of the two conditions. So always calculate both and pick the higher headwater value. For a memorable shortcut, just think, for culvert control, calculate 2, pick the high one. This will keep you from making the common mistake of choosing the lower, less restrictive headwater depth. These systems are typically designed to handle storms of a specific frequency, such as a 25-year or 100-year event, which will be specified in the problem statement. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.